All right, welcome back, family. Simple pendulum problem. So we're going to pay attention to the arc length piece now, and we're going to focus on just pretty much when we can use this this F equals negative mg sine of theta equation, and when we can derive a different form of it based off a given situation. All right, and so again, we know that a pendulum has a harmonic motion, meaning that it moves in a sinusoidal motion where it has an amplitude max, right? It has an equilibrium point where it begins, and then it does the exact same thing on the other side. It has a tension force that is keeping it up with some length L, and it's going two-dimensionally, so it has some angle, okay? This part here, we said that pretty much this is the force, it's the force of gravity that is pretty much causing this motion when it's hit with some type of force in some direction, depending on where it's coming from, some applied force, right? And so we say that the gravity is always pulling down, but there's also components on it. So because it is moving in two-dimensional, there is gravity that's pushing it two-dimensionally. And that's what this FGY stands for. That's what this FGX stands for. All right. And then we see that there are some type of symmetry here. So we can say that if FG, even though, FG of X is going to be the opposite, so that's sine of theta. And we can say that that direction, this vector here, pretty much the force that causes it to move is going to be negative mg sine of theta, okay? And so let's pay attention to the arc length piece, and we're going to just do a quick derivation to just show you how this equation can evolve. All right, and so arc length again, so if we have a circle, all right, and then we have some radius. Arc length is the path you travel on the circumference of a circle. Okay, so this piece right here is the arc length. All right, and sometimes we use X, sometimes we use S, okay? But arc length is very important. So in this case, we're going to use arc length X is related to L, right? And if we solve for if we solve for L, my apologies, if we solve for theta, then we get an indirect relationship between theta and the length, and proportional relationship between theta and the S or the X, okay? For very small angles, so let's say we have a very small angle for this pendulum, okay? So let's say that let's say that it gets pushed, but it gets pushed, zoom in. It gets pushed an arc length like that,